All right. Oh, okay. Looking at the wrong screen. Yeah. Okay, so. All right, I'm going to close many of these tabs. Yep. I want you to submit the source file. Source file means, it is the code that you copy and paste into the assembler. So, not the RAM file. The RAM file I cannot read easily. Okay. So when I talk about the TTP ASM, that's the source file. That's the assembly source file. Yep. No, this is the sample program, or a variation of the one that we talked about on Monday. This is from the Tuesday, Thursday class. So instead of subtract, instead of add, I use subtract. So close enough, but different. All right. So what we'll do tonight is just talk about recursion. So since we can do subroutine calls, we know how to pass the return value of a subroutine invocation as a parameter, as an argument to another invocation of the same subroutine. So I think we are ready for recursion. So what do you think I should use for this example of recursion? Most people like to use factorial, but I'm going to use something else. So I'm going to use something like this. Okay. I was looking up curl because I was helping out someone over at theater. They have these projectors that can project like the background in a theater production. So they're kind of like the projector that we have here, except I think it is brighter and it has a built-in shutter. In other words, it can physically shut out all the lights. So there's no leakage, whatsoever. Because even when the screen is completely dark, there's still some leakage, out of these projectors. As it turns out, the projector itself has a web server. So the way you talk to the projector and ask it to do something is to use a web client like Firefox, and then you just log into the thing, and then you just do your thing. Except the guy wanted to automate the whole process, so he has to kind of reverse engineer the protocol, like what kind of request with what kind of parameter will turn on the shutter and what will turn off the shutter. So he replicated the GET request, except he didn't do it. It's because in the HTTP request, there's also the header, and part of the header is the referrer of the web page. So he didn't get the referrer correct, and I was looking up curl to look up how to specify the referrer part of the HTTP request header. So we finally got the whole thing working in about, I would say about 20 minutes. We figured it out. So he took me to a back room tour of the stage and all the cool stuff. Everything is now computerized. All the lighting equipment, and even the fogger, they're all computerized. So it's a gigantic computer network, that's actually controlling the entire stage. So it was really interesting how the stage work now. Okay, so getting back to what we want to do. I'm going to implement string length. So how many people have encountered or have at least know what string length is from your CISP 360 class? Okay, what does it do?
It returns the length of a string.
It returns the length of a string. Very good. Okay, so we can easily do this without recursion, but I'm going to do a recursion just because we can. Okay? Well, that's usually not a very good reason to do something by recursion, but I'm going to do it by recursion because I want to illustrate how recursion really is not any different from any other subroutine invocation. To come up with a recursive algorithm to do something may be a little bit challenging, okay? But if I give you the algorithm, the implementation in assembly is no different from any other function call. So we'll work with this one tonight as an example, okay? It also uses pointers, but we know how to use pointers already because the swap homework assignment, also uses pointers. So if you have not completed that homework assignment, maybe this one will give you some idea of how to get it done. Okay, So for those of you who have not encountered string length, which I will be kind of suspicious about, string length calculates the length of a string pointed to by s, which is a pointer, excluding the terminating null byte. So that means an empty string where string length should return a 0 would be just the null byte itself. The pointer points to a byte that is just 0, which is the null terminator. Are we doing okay so far with this? Is it cool? All right, okay. So the first thing we want to do is we're going to write the subroutine in C first, okay? And then we can test it, make sure the logic is right before we try to implement it in assembly, okay? So I'm going to do a string length.c, okay? And we'll go ahead and use pound include stdint.h. So if you have not made it a habit to use standard integer.h, make it a habit, okay? Because one day it's going to save you a lot of time. And then we'll go ahead and write the subroutine. So let me just go back to the man page just to double check on the protocol. Oh, okay. We can shut down Logisim for now because I probably have to reset the whole thing anyway. So okay. I'm checking the type here. So size t is probably some kind of an integer type. Char is actually signed. So I'm going to follow all those conventions. So we'll go back to my editor, which is another tab here. All right, so I'm going to say int 8 underscore t string length. And then the prototype is const. Char is basically, okay, I'm going to use char here. PTR, like so. So PTR is a pointer. The pointer itself is not a constant. What it points to is a constant. So this means I'm free to change the pointer, but I'm not free to change what it points to. Is that okay? Because there are two ways to put const. This is one way, and then the other way is to put a const between the char and the asterisk. In that case, the pointer itself is a const. I cannot change the pointer, but if I don't have this first const, only the second const, then I can change what it points to, but I cannot move the pointer itself. So are those concepts introduced in CISP 360? Okay, very good. All right, so I'm going to turn this into a recursive subroutine, which means I have to think of the base case. In other words, I have to think in a lazy way and go like, in what case do I have nothing to do? Okay, that's the base case because I got the answer right away. I don't need to call the subroutine again. So I need to figure out some code that has this kind of format. And depending on how comfortable you are to use a return inside the conditional statement, you can put it inside the conditional statement, but I would personally not do that. Okay, so we'll do the first version like this. Okay, so result is a local variable, and then in both branches we'll set result to something, and then we'll return it at the end. All right, so can someone think of a very easy case so that I don't need to do any recursion? I know the answer right away. In what case can I know the answer right away? The length of a string.
String.
The empty string. Okay, so how do I know this string is empty?
It's pointing to what is it?
Okay.
Nowhere character.
All right. So basically, if I say not star PTR, that's a very cryptic shorthand in C to basically say if what PTR points to is a 0. Okay, because it really is the same thing as saying star PTR equals 0. But instead of using the comparison, I'm just being tricky here and use the negation operator. Because in C and C++, if let's say we're not considering the exclamation point. If I just put asterisk PTR here, that means if whatever PTR points to is non-zero, then we go to the then branch. But with the exclamation point here, that means if whatever PTR points to is 0, then we go to the then branch. Is that okay? So I'm not intentionally trying to teach you guys, cryptic C code, but you will see C code like this in your career if you're getting into C and C++ programming. So I just want to make sure that you understand the code of what it means in this expression. Okay, so PTR points to a null char. We know the answer without recursion. Okay, because result is just going to be a 0. The length of this string is 0 because the pointer points to a null terminator. Is that okay? So that means in the else case, PTR points to something other than a null byte. Okay, so we'll just restate it here. PTR points to a non-null char. Okay. So in that case, result is going to be, let's call it recursively, strlen. But this time I'm going to say, I already know what PTR points to. It's not a null character. So I want the next invocation to deal with the rest of the string. Okay, so tell me how long it is for the rest of this string, and then I'll just add 1 to my own answer. Is that making any sense? So whatever the rest of the string has, I just add 1 to account for whatever PTR points to, and that becomes my answer. So that's the recursive version of string length. How does it compare to the non-recursive version, which is a while loop? Well, do you guys know what it looks like, the non-recursive version of string length? Yes? Okay, I see some nodding and some people express no expression, so I'm not sure whether those people get it or not. So, yes? Okay? All right, okay. So unless somebody asks me, I'm going to assume that you guys know what the non-recursive version look like, okay? So we're going to focus on this one. All right, so name integer main, and all we need to do is to have a int8 underscore t. Let's call this x here, and we'll say x equals to string length of a literal string. So what that means, I'm going to use double quote to start and end the string. So we'll call this, okay, tax toy processor. Okay. In my assembly code, I'm not going to make that string that long because it's going to be a pain to do that. I'll show you guys why that is the case. All right. So here's my sample program. If everything works correctly, the string length, or x, should have a value of, let's see, this is 15, and that's 34. So 34 minus 15 is 19, I think. Yeah, I think it's 19. Let me double check. So 19 there. Okay, yep. So x should be 19 when string length return the value. Is that okay? Yep. The alternative is to put a return inside the branching, inside the branch. I philosophically, I do not like that. So syntactically, it is okay, it is acceptable, but as a kind of rule of thumb, I don't like to do that, because if that becomes a habit, then I will start to put a return into a more complex conditional statement, and then I'll start to put a return inside a conditional statement that is inside another conditional statement, and then I'll start to put a return statement inside a conditional statement that is inside a loop. So at some point, the concept of structured programming is not going to be followed anymore. So I don't want to even start on that slippery slope. I just say, do not return inside a branch. So I know a lot of times, professors, like to put a return inside a branch. Now, if that is what you guys want to do, and say, okay, this is much more complicated than it needs to be, right? I mean, that's the usual complaint. Is like, we don't really need a local variable to store the value and then only to return it later, right? Are you guys thinking about the same thing? This is more complicated than it has to be? Okay, If this is more complicated than it needs to be, and you guys go like, this is not elegant code, fine, we'll do it some other way. Too late now. Okay, so we're going to do a single return statement this time. No local variables, no conditional statement either. Okay, so this time we're going to do it like this. Okay, if PTR is non-zero, then we return 1 plus the rest, the length of the rest of the string. Otherwise, we return to 0. We use the ternary operator instead. The ternary operator, are you kidding me? You will start to like it once you start to use it correctly. Yeah, because it's basically an if-then-else statement in the form of an expression. Okay, so concept-wise, it is the same thing as an if-then-else. So that's the condition of the if. This is the then value, and this is the else value. So if you don't need to perform any actual statement, like calling a subroutine that does not return anything, this will give you the same effect as a conditional statement, except it is not a statement; it is an expression. Now, because it is an expression, it can go places where your if-then-else statement cannot go. This can go into an argument when you pass an argument to a subroutine. This can be inside an addition. It can be inside any type of calculation. So it is actually more flexible in some way. It is more flexible than a conditional statement, than a simple conditional statement. And so by using this, I don't have to return inside a conditional statement. I do not need an extra local variable. And the logic is really, at least to me, just as clear. Okay? It just gets some getting used to. Okay? All right, so we'll implement it like this. Okay, that's fine. So the program just got a whole lot shorter, doesn't it? All right, so first thing first, let's check this program, make sure it is correct. So I'm going to save the program, gcc-g-warn all. It's going to give me one warning because we have local variable x that is initialized, but nobody's using that value later. So string length.c. Okay, it doesn't like that either because I'm redefining the name string length. It only reports it as a warning. In other words, I'm defining a function that has the same name as a built-in function. So even though I did not pound include string.h, which includes the prototype, the compiler is smart enough to understand, hey, we have a function like that. So it doesn't, it gives me a warning when I redefine it. It's just a warning, it's not a big deal, but I'm just kind of surprised that it's smart enough to do it. Okay, so we'll go ahead and debug the program. And, oh, this is a good one actually, because I can put a breakpoint at the entry point of string length. And then we also want to put a breakpoint on line 13, okay, just right before we return, because then we can check x. And now we can run the program. All right, so when I run the program, this is the first time we call string length. And you can see the first time we call string length, we have the entire string because this is being called from main. How do I know this is being called from main? From this screen, you cannot tell. If you type BT, which is backtrace, then you can tell that this is the first invocation of string length, and it is called from main on line 12. Is that okay? So the next thing I'm going to do is to do a continue, C for continue, and now we stop again. So you might say, okay, are we stuck in an infinite loop of some kind? Is the stack corrupted? Is that why we're stuck in a loop? Nope, that's not the case, because if you look at the string being passed, it's missing a T this time, because it is the recursive call. Okay, the first character is taken care of by the first invocation of string length. The second invocation takes on from the second character and on. So that's why this time it is from A, K, and then so on and so forth. Is that okay? You can look at the actual address as well. In the first invocation, it ends with 7.4. In the second invocation, it ends with 7.5. So we can definitely tell that this is PTR plus 1 relative to the first invocation. Okay? And then we can continue a few more times, okay, just like that. But at this point, if I do a BT, you can see that we actually have, not figuratively speaking, but technically speaking, a stack of invocations of string length. They're all on top of each other. So this gives you a pretty good visualization of recursive subroutine call. Every single invocation is still on the stack. It's just that we are putting additional invocations on top of those that are already active. Is that okay? Or are there any questions? So this is going to get pretty lengthy. So I'm going to delete my first breakpoint and just continue execution, because I kind of know that this is going to return the correct value. So I just continue all the way to the return 0 statement in main. And then we print the only variable in X. And that's 19, which is correct. We do have 19 characters, not counting the null byte in that particular string. So the program did work correctly. Now it's our turn to turn it into assembly code. Are we doing okay so far with this? Are there any questions about the recursive nature of this implementation? Not a question about the assembly implementation, but about the C concept of calling a subroutine from inside quote-unquote itself. No questions? Okay. When I was a student and first get introduced to the concept of recursion, I always have this kind of question in my mind of, well, the subroutine is still being defined. How can it call itself when it is still being defined? Okay, that's my question. Okay, but it was my misunderstanding because I didn't know about the compiling process. In other words, when the program runs, the whole subroutine is already compiled. Okay, the recursive call itself is nothing more than going through exactly the same motion as when you call any subroutine. So the motion or the mechanism of calling a subroutine from inside itself is no different compared to calling a subroutine from any other subroutine. It's the same mechanism. It's just that your destination turns out to be the same subroutine that you are in at that moment. Okay? Right? So we'll go ahead and turn this into assembly code. So I'm going to copy the C version into strlen.ttpasm, text toy processor assembly. Okay, so that's why I call it ttpasm. It's the source file. So I go into the assembly file, and the first thing I need to do is to put comments in front of each line. Okay, I might have used this before. Oh, okay, I'm substituting the beginning of each line with that. There we go. Okay, and now we can start to write the actual code. So we'll start with main. I'm going to move main a little bit forward. So we have, this is 8. And we'll put everything ahead here. Okay. All right, so before we get into main, we have to initialize the stack pointer. So, we have a sub dd to subtract d from d so that d is 0. And then in here, we have to allocate the space for local variable x, which means we have to decrement the stack pointer by 1 in order to allocate a byte. And then over here is the tricky part, okay? Because we have to pass the address of a string, and the assembler actually has no mechanism of defining a literal string. So now we have to kind of think about, okay, so what is that? What does it really mean when you say double quote, blah, 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 and then end double quote? How is that actually done in C and C++? Well, as it turns out, it is really the same thing as defining a string that has a name and then refer to the name here. Except in this case, a literal string has no particular name. It is not a variable that you can refer to. Okay? So the way to do this in assembly is really kind of tedious, because what we need to do here is to say we have a literal string as a label, and then we have to use the byte thing to define every single character. So now we have to define the ASCII code of uppercase T, the ASCII code of lowercase a, and so on. Okay, which is really kind of tedious. I believe the uppercase characters start at 48 plus, A is +1, B is +2, and so on. Now, let me double check. Man, ASCII. Okay, so we are looking for uppercase T. Well, actually, if I know lower uppercase A, that would be fine. Okay, so I stand corrected. I was wrong. A is 65, so it's 64 plus, at least 1. Okay, so we can now switch back. And so this is T. Okay, I should have just looked up the table, shouldn't I? Okay, so uppercase T is 84. So we have 84, and this is basically uppercase T. And then we have lowercase a. Lowercase a is 97 because it's 96 plus 1. So that one I know for sure. And then we have K, which is A, B, C, D, E, F, G, H, I, J, K. So that's plus 11. So 97 plus 11 is 108, I think. Okay. Well, we can always double check and look for lowercase t. Oops, lowercase k, sorry. I can't even spell my name. So lowercase a is 107, and I got, I'm one off. Okay, there we go. So I'm just going to be a little bit lazy here and put a null character right at the end. So this is how we define a quote-unquote literal string in assembly code. It's really just to use a label so that I know where I need to refer to, and it's just a whole bunch of byte to spell out the individual characters. Okay, the C code does it in a very similar way, except there's no actual label that you can refer to because it's all internally handled. Okay, all right. So now that we have a literal string, how do we pass the literal string on a stack? A literal string is an array. In C and C++, you cannot pass an array by value. You always pass an array by address or by pointer. Okay, so we are really just literally passing that label on the stack. So we do a LDIA with the label name, which is lit string, decrement D, stda. So these three instructions together is really pushing literal string, which is the address of the string itself on the stack. That's the only argument. We can now save the return address on the stack. So return from string length is here. Decrement D, stda. So this time we are pushing the return address on the stack. So with both of these items pushed, I can now actually call or continue execution in the subroutine. So we have a JMPI instruction to string length. I'm keeping the same name with the subroutine. And here we define the label to return to. Uppercase L. And then we do an increment D to deallocate the parameter or the argument of string length. So at this point, the stack should be balanced. D should point to what again at this point? What was D pointing at before the call to the subroutine? The local variable x. So because I just make sure the stack is balanced at this point, it should point to local variable x again. What about the return value? Where's my return value? By convention, how do I pass a return value back to a caller? Register A. So register D points to where I want to store the value. Register A has the value that I need to store. How handy, right? Because a single store instruction can now store the return value into my local variable x. So stda will perform the x equals to strlen part the assignment operation is going to be finished by this single instruction. So at this point, we're at the end of the whole program. So we are pretty much at the return statement. So the only one thing we need to do is to increment d one more time. And this time we are deallocating the local variable x. And since there's no place to return to, so I just put a halt instruction here so that I can tell the program is done. Are there any questions about main and how the C code is implemented in assembly? Is that okay? More or less? Okay. All right. But that's not even the main point of this program. The main point of this program is how do we do recursion, and that's the string length subroutine. So now we move on to string length itself. This is the entry point. The entry point is nothing more than just a label of the name of the subroutine. But I also usually want to know what is on the stack. What can I count on the stack at this point? Okay. So just as a habit, I always indicate what is on the stack. So PTR is on the stack, and then right below PTR, which means at a lower address, we have the return address back to the caller, and then register D is always pointing to the return address at this point. So this is really important. I saw someone doing the homework assignment or the long lab by looking into the actual code in main and say, oh, I know register C is pointing to this and register blah, blah, blah is doing something else, and not by using the convention that the stack pointer always points to the return address on the stack, and then one byte on top of that is the first argument, and one byte on top of that is the second argument. So I told that person, you cannot look into how the caller is doing the call and then write your subroutine to match that, because you can never tell who's calling you, right? Or the mechanism of calling. So the only thing your homework assignment should count on is at the entry point of a subroutine, D, register D points to the return address, and then all the parameters are on top of that. That's the only assumption you can make. You cannot assume what the other registers are containing at that time. Did you do it that way too? Making the assumptions? No? Okay. That's all right. Okay. So now we need to implement the actual logic, which is a single return statement. Okay. But the first thing we need to do is to figure out what is PTR pointing to. Okay. At least we need to know whether it's a null or not. Okay. That's what we need to know. Okay. But before we can tell what PTR is pointing to, we need to know what PTR is. But before we know what PTR is, we need to figure out the address of PTR. Is that making any sense? So we need to, okay, first compute the address of PTR. So the following code is going to do that. So the first thing is, I don't like to mess around with a stack pointer because of interrupts. So I make a copy of the stack pointer. So at this point, register C is the address of the return address on stack. I increment C so that C now becomes the address of PTR, which is the address of the parameter. This is not the parameter itself, it's the address of the parameter. By dereferencing it once, using an LD instruction, I can dereference C into C. That's actually legitimate. So now C is PTR. In other words, at this point, C is the parameter itself, which is a pointer as well. Okay, it's a pointer to somewhere else. But that's not what I'm interested in. I'm interested in what the parameter itself is pointing to. So I need to dereference it one more time. So at this time, C is whatever PTR the parameter is pointing to. That is what I'm interested in. Now, if you look ahead a little bit, you would probably know that we probably don't want to destroy PTR. Or we don't want to change the fact that register C is a copy of the parameter, because we'll need it back later on. So if you can kind of anticipate that a little bit, then you go like, maybe we'll just do it with another register. We'll put it into B, okay? So that register C continues to be the parameter itself, not what the parameter is pointing to. So now I need to know whether it is 0 or not. The most conventional way to check whether it is 0 or not is to do LDI A0 and then compare to register A. Okay? That's really cumbersome because you need an LDI instruction and then you need a compare. But we can do all of that using, guess what? You have seen this one already. No, JCI is what we need eventually. But before the JCI, we need to do an operation just so that the value of register B goes through the ALU to set the flags, but without necessarily changing the value of register B. So do you guys remember which instruction can do this? Yep, exactly. It's AND BB, okay? So we can perform an AND operation, B with B. So AND BB does not change the value of B because B and B have exactly the same bits, right? 1 and 1 is 1, 0 and 0 is 0. So it doesn't really change the value of B, but because this is still an ALU operation, the result of the AND is going to set 2 flags. Yeah, 1 flag, sorry. 2 flags. It will set 2 flags for sure. It will set the 0 flag, or change, I should say, it will change the 0 flag depending on whether B is 0 or not. It will also change the sign flag, which we don't really care in this particular application. The overflow, carry, and L flag will not be affected because of the way I structure the ALU. Okay? So after this, now we can do a JZI to basically say, if it is 0, okay, if PTR points to a byte that is 0, then we go to the else value. Okay, so else value is going to be defined somewhere here. But if I continue execution without going to else value, that means B is non-zero. If B is non-zero, then we have to perform the then branch. So the then branch, even though in the C code I wrote it as 1 plus blah, 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 well, you still have to call the subroutine first. Get the return value back and then add 1 to it as your own return value. So we have to do the recursive call first. So I will just emphasize here, this is where we do the recursive call. So to perform the recursive call, we have to figure out, okay, what is PTR again? And then we have to add 1 to it before we push it on the stack. Okay? So with all the registers at this point, which one should I use? I mentioned a little bit earlier that I intentionally did not destroy register C. Yep, register C is the one. But register C by itself is not quite where I want it, so I have to increment it first so that it becomes PTR plus 1. Yes? Why I use AND? Yeah. Okay, so bitwise AND, which is what the AND opcode is doing, is performing a bitwise AND and then store the result back into the same register in this case. Now, if you look at bitwise AND, 0 and 0 is a 0, 1 and 1 is a 1, so that means it really is doing nothing. As far as changing the value of register B is concerned, it's not making any changes. But all of that is still going through the ALU, and as a result, the flags, 2 flags will be affected. The Z flag is affected, the sign flag is also affected. And I'm counting on it to change or affect the Z flag so that if B is in fact 0, the Z flag will be set, will be a 1, so I can branch to the else branch. Is that okay? All right, cool. So I'm going to increment C, and after the increment, C becomes PTR plus 1. So I need to change the comment here because this is actually incorrect. This is B, this is C. So once C is PTR plus 1, I can push it on the stack. So we do a decrement D, STDC this time. So now we are pushing PTR plus 1 on the stack. And then we can push the return address. So we LDI A with return from, so I have to be careful now because I have to say strlen return from strlen because it's recursive. So we are returning from the same subroutine. decrement D, stda. So we are now pushing the return address on the stack, and then the JMPI back to the entry point of the subroutine itself, which is string length. And we define the label strlen, return from strlen over here. And then we always increment D so that we deallocate the argument to string length, the recursive call itself. So now the stack is balanced. And the return value is an A. What should I do next? Remember, I'm implementing this portion here. We just got back from string length, and there's only one more thing I need to do, right? I just need to add one to the return value of string length and make that my return value. Is that making any sense? Yes? No? Okay. So at this point where the cursor is, we are done doing the recursive call. Is that part okay? So at the end of the recursive call, register A has the return value of the recursive call. So I got this part figured out already. But that is not my own return value. My own return value is one more than that. There's a 1 plus. So I just have to add 1 to the return value of the recursive call, and that becomes my return value. Is that okay? And how are we going to do that? Increment A, exactly, because the return value of the recursive call is in register A already, which is what I need to use to return my own value, but I just need to add 1 to it. So increment A is all that I need to do. Increment A is basically 1 plus, okay, the return value of the recursive call. But I have one little thing here that I have to be extra careful about, is I need to branch around the else branch, because otherwise it would just kind of fall through and do the else branch. So I need to branch around the else branch. So I need to go to strlen return, which is a label defined later on. Okay, we'll define it over here. And now we can specify, okay, what about the else case? What is the value that I should return when I'm over at the else? Oh, that's just a 0. So how do I make sure that register A is 0 at this point? There are 2 ways to do it. They're equally fast. So how do I make register A 0 at this point where the cursor is? Okay, so sub AA would do it. Okay, cool. Okay, sub AA definitely gets the job done. There's another way too, because the only reason I end up here is because something is 0 to begin with. So I can do a CPR. Yeah, I can do a CPR AB, and that will also guarantee that A is 0. Now that one is a little bit more convoluted, because I have to kind of keep track of the values of the register, because the only reason why I ended up here is because of this branch. But the only reason why this is branching is because B is 0. So to make use of the fact that B is 0 at this point is kind of convoluted. But I do want to make sure that you guys understand that once I point it out, you really should understand why B has a value of 0 where the cursor is. So I do not recommend that particular way of doing it, CPR, AB, but you should understand why if I did use that, it would still work. Okay. All right. So sub AA it is, and now we have the usual return, which is LD. Okay, I cannot use register A because that is dedicated as the return value register. So I can use register B or D or C, excuse me, not D but C. So this is for me retrieve return address increment D to deallocate the return address, and then we have a JMPB to continue execution in caller. So that's the implementation of string length as a recursive subroutine. Are there any questions? Do you guys see how recursive subroutine call really is no different from a normal, quote unquote, non-recursive subroutine call? It goes through exactly the same motion. You push all the arguments, you push the return address, you continue execution in the called subroutine, then you clean up all the arguments. It goes through exactly the same motion. Where's the return value? In register A, just like any other subroutine. Is that okay? So there's nothing mysterious about recursion at all. So once you understand how recursion is done using assembly and how the stack is being used to store the arguments, return address, and local variable, if any, then you go like, oh, okay, so there's no mystery whatsoever when you have to write something that is recursive. Now, it doesn't mean that recursion is the answer to everything, even though conceptually it is kind of elegant, but it is not really the answer to everything because every level or every invocation consumes stack space, and you only have so much stack space. When you run out of stack space, your program will crash hard. Okay, it's not like throwing an exception and go like, okay, but I can catch it and do something about it. Nope. When you run out of stack space, you're done. There's no recovery from running out of stack space. Okay, so that is the reason why we do not use recursion to implement things that can easily be done using a loop. But conceptually speaking, a lot of things can be done recursively. So are we good so far with writing this code? Question? Oh, okay, never mind. Huh? No, tonight's lab is a continuation with the long program that we are writing. So I'm giving people just one more lab session to finish that program. If you have any questions about this program, we can talk about it. Okay. So are we good so far with this code? Are there any questions about any line of code in this program? Anything you want me to explain at all? No questions? Seriously? Okay, yep, go ahead. Okay, thank you. No, it's coming from an ASCII table. No, ASCII stands for American Standard Code for Information Interchange. I'm not a standard committee, so it is actually set by a national committee of what bit pattern is used to represent which letter or which punctuation. Yep, you can use Google to find it. So if you go to Google and you just look up ASCII, and the first one is a wiki. No, it's not wiki. If you go to the Wikipedia one, it gives you a brief history of what it is, who said it, and so on and so forth. ASCII stands for American Standard Code for Information Interchange. It is not the first encoding scheme, by the way, to encode characters with binary bit patterns. The first one that is widely known and widely used is called EBCDIC. Is anyone old enough to remember EBCDIC? Okay. EBCDIC is interesting. Okay, so since we are on that topic, we might as well go a little bit further to look into it. So EBCDIC. Just the name itself is extremely convoluted. Okay, Extended Binary Coded Decimal Interchange Code. Okay, so it started off with BCD, which is binary coded decimal, which is already confusing. So is it binary or is it decimal? It is binary coded decimal, which means it is a way to represent decimal using binary. Yep. It is very old. So back in those days, mainframes do not like to do everything in binary. They like to do things in BCD or binary coded decimal because they don't want to lose precision. They don't want to use double precision floating point representation or anything like that. So what they did was they used a nibble to represent a base 10 digit. Okay, so let's say we want to represent the value of, like, I can do this on the whiteboard because it's kind of not a part of the class. So let's say we want to represent 4,501. Okay, so these days, okay, we look at this and go convert it into binary, which is 4,096 plus some other powers of 2, right? Okay, but back in those days, the BCD binary coded decimal days, that's not how this number is going to be encoded. They look at 1 and go like, okay, 1 is 0001, a 0 is 0000, just like hexadecimal. 5 is 0101, and then 4 is 0100. This is 1 byte, this is another byte. So these 2 bytes with this particular bit pattern represents 4,501. Now, huh? Well, it's very wasteful. It is very wasteful, and any type of computation will have to basically line up and say these 4 bits add these 4 bits, but the carry is the tricky part because you're not going to use, you cannot just use binary addition. Okay, so let's say the next number has this bit pattern. Okay. This is 1, this is 9, that's 19, okay? So when you add these 2 numbers, it's really tricky because if you just look at this as a hexadecimal number or binary number, you go like, well, we have a carry right here and that's it, right? So this becomes 1010. But in BCD, that is not the case because we have 1 plus 9 and it is base 10. So it becomes 0 and then you have a carry here. So this becomes 0010, and then this one is just 0101 again, and this one is just 0100. So there are really kind of tricky circuitry just to do this. But IBM had to do it because all the banks were using base 10 to represent, currency, how much money you have in the bank, and so on and so forth. But they actually do not represent dollars. Okay, they represent, I think it's either 10th or 100th of a cent, okay, for precision purposes. So when you calculate interest and stuff like that, the internal calculation would actually calculate to like 2 decimal places after a cent, so that they can get a very accurate, representation. Only when it needs to be converted into something to actually credit or debit from your account, then they do all the rounding. But the internal calculation is fixed to use 100th of a cent or something like that. And it's all in base 10, so how much money you have in your account is represented exactly, but in base 10. That's the good old days. Okay, so anyway, this is BCD. So EBCDIC, which is the extended binary coded decimal for information exchange, information coding, or information code, interchange code. Now the table doesn't make a whole lot of sense. Okay, I have no idea they make this table this way, but when you look at this table, A, B, C, D, E, F, I is over here, and then J is over here. So they're not contiguous. The EBCDIC code of I is not right next to the EBCDIC of J, which is awfully confusing. And that's why we are not using it. It came first, but it did not get accepted by most people except for IBM. And that's why, ASCII is now the current standard and not EBCDIC. EBCDIC has a few other pitfalls too. So anyway, that's a brief history of how we encode characters into binary bit patterns. Okay, so getting back to this program, I think this program is done. So next thing to do is to use mousepad because I need to copy and paste it into the assembler. This is called string length.ttpasm. Control A, Control C. And then we go to the assembler. Go to the source tab. I locked down most of the things that you are not supposed to change, so hopefully it is not as easy anymore to kind of mess up the spreadsheet. Okay, so then we go back to RAM file. Download as strlen.csv. Then we start Logisim. Well, you guys don't see that because you have faster computers. From a command line, yeah. Yep, that's always the only way I do it. Okay, load the processor in. Load the RAM image. It's called strlen.csv. And so now we are ready to run the program. So before we run the program, we kind of want to know what we expect it to do, right? So what do you think is one thing that we should count on that it will do? What do you think the local variable x should end up as a value? 3, because TAK has 3 characters, and then I intentionally put a null character in the end so that it would end. What should be on the stack other than the local variable x? Because we do have a recursive call, right? So with each recursive call, how many bytes is it going to take? Each call to string length is going to take up 1 byte for the argument, 1 byte for the return address. And how many times do we have to call before we say, okay, that's enough, now it's time to return? How many times? First time, it is TAK, no character. Second time, AK, no character. Third time, K, and then a no character. Last time, it's just a no character. So there are 4 invocations stacking on top of each other. And each invocation takes 2 bytes. So the calls to string length should take up 8 bytes on the stack, plus the local variable x. So 9 bytes on the stack should be used in this particular case. Is that okay? Now, I'm predicting all of these things because if my observation using the log ability is not consistent with what I think the program should do, then I have some explaining to do. Okay? So before you run the program that you write, okay, you should do the same thing, okay? Figure out how many bytes should be used, what should be at a particular location, and so on and so forth, okay? All right, so we'll go to simulate and set up the logging. So just like the usual, we go to the register, we go to program counter, always log the program counter because it's extremely helpful. And then always log the stack pointer, which is in the register bank known as register D. And then we can go to RAM and log the last 10 locations. I know I'm only using 9, but just in case I did my calculations incorrectly, I want to be able to catch that. So we scroll down. And unfortunately, I don't think Logisim can deal with like block select. So we are going to start with 296, 297, and then change each one to base 16. Yep, I mean I'm doing all this with a touch point on the keyboard. There we go. Close window. Oh wait, there's one more thing, because I want to log it to a file. So we have to go to File, and then specify string length .tsv for tab separated value. Now we can start the program. So Control K, run the program at full speed. It's done now. And the first thing we can do is to just look at the RAM content and focus on the last few locations. So we want to say, do we end up with a 3 in local variable x? Yes. Okay, cool. Are we using only 8 additional locations for the invocations of string length? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. Exactly 8. Okay, so it seems, I mean, you can never tell because I could have pushed a 0, 0 on the stack. Okay, so you can't really tell. When we look at the log, we can tell because we can track down the value of register D and see how low it got during the execution. So we can confirm that later. Okay, but are those values correct? In other words, 10 or 10, 11, 12, 13, what are those? That's the argument, right? Does it make sense they're just they're incrementing? Makes sense because each time we do a recursive call, it is passing PTR plus 1 relative to the current PTR. So they should be incrementing just like that. The return address, okay, which is 0C and then 242424. Wait, so the first one is different and then the 3 other ones are the same with 24. Is that right? The first one was called from main, so it had to return to main. So that means the 0C is a return address in main. Now we can check that in the assembler. Okay, the assembler actually has that information as well. The other 3 are recursive, which means they are returning to one point in string length itself, and it's the same point because I only have one place that is doing the recursion in string length. So all of those return addresses should map to the same address. So far I can explain what is in memory. Is that okay? So that gives me a feeling that the program is working correctly. One more thing I can check. I have to check the stack pointer, make sure that it is balanced, which means it should start with the value of 0, should end with the value of 0 as well. So that's one thing I can also check in the simulator without going into the log file itself. So let me close this, go to the register bank and look at it. Register D, in fact, is a 0. Okay, so that gives me a kind of warm and fuzzy feeling, if I had any like that, that the program is working correctly. But if it doesn't match, then I will track down in the log file and find out why it is not behaving the way I expect it to behave. So are we still doing okay with this stuff? Okay. We got about 10 minutes left, so I will do 2 announcements and then we'll see how much time is left and we can talk about additional concepts. So the first announcement is the Design Hub recruitment thing. So let me, I'm going to introduce it to this class too. So Design Hub. There we go. Internship recruitment event. So it is tomorrow from 10 to 12 or 10 to noon. The location is the center of the ARC Student Center. Do you guys know where that is? Okay, the Student Center has it's kind of like a donut. There's a donut hole in the center. That's where we are. In other words, if you're in the Student Center, you think about where are you going to be in the Student Center when it rains, you will have water droplets on your head. That is where they're going to hold this. Yep, exactly. You don't have to bring a resume. The whole idea of this particular event is for the Design Hub to let you know what projects they're going to have in fall 2018. And if you're interested, then you know that you can go through the online process. They have an online form so that you can submit your interest. I think there's a way to collect your resume and whatnot. So you don't have to bring your resume tomorrow. Just kind of go to the event and ask questions. Okay, look at what is the projects that are active, and then just ask questions. The Design Hub. Anyone know about the Design Hub, like what it is? And no one. Okay. So the Design Hub is kind of like our Makerspace, but it's not a makerspace. When I mention the word makerspace, what do you think of?
It's where you have like they have one at the local library, right? Like where they have 3D printers and laser cutting classes and so forth.
Okay,
It's awesome.
so they do have 3D printers, they do have laser cutters, they do have all sorts of stuff. Okay, and they have access to laser cutters that can cut steel, not just etching on wood. It can actually cut steel. So we're talking about major output laser here. Okay, but the format is not the same thing as most of the other makerspaces, because most of the other makerspaces is like, okay, use our equipment and do something cool, and I'm just gonna walk away and let you do your thing, right? This is not the same. This is actually more like a work environment. It's kind of like a clearinghouse. So around the campus and in the community and from actual commercial entities, they would send us projects to do. And then the professors who are participating in the design hub will kind of act as supervisors at work. And then the students are the employees who are doing the work. So you'll be working on actual jobs that are of value to someone. That someone can be on campus, can be off campus, can be commercial, can be non-commercial. So when you 3D print something, when you 3D model something, you're not just 3D modeling something that is just kind of fun to you. You can do that stuff too. But for the most part, you'll be working on real projects that actually has real value, and you'll be evaluated as well, just like at a real workplace. Except you're an intern, you cannot be quote unquote fired. You may or may not be paid. I think they pay up to $11 per hour. I cannot be 100% sure, but I think that's the approximate amount that they can pay. So you might think, okay, but it's a makerspace, I'm a software person, why would I be interested in a makerspace? They have a lot of software projects. I'm not just saying one or two, I'm talking about a lot. They got game engine projects going on. So if you want to learn how to use Unity to do something useful, they got projects, okay, in Pro. They got an actual video game going on. They have a cancer active site visualization project that will be active, in fall 2018. So you'll be helping someone to visualize the molecular structure of an active site of cancer, and also visualize the molecule of a cancer treatment molecule. And you will try to kind of fit those things and figure out whether a particular drug is a good fit or not. Okay. There's also the visualization of physics. So somebody from physics is going to supply all the equations about the decay of subatomic particles and the rules of gravity, charges and whatnot, and we're going to use Unity to visualize the molecules and atoms and subatomic particles spinning around and doing their things. If you want to be practical, more practical, and not do game engine stuff, they have projects to use Google Script. What is Google Script? What is it used for? If you use Google Documents or Google Spreadsheet, you can actually write your own macro using Google Script. So it's a way to automate certain things that you can do in spreadsheets, documents, presentations, and that kind of stuff with Google products. And the syntax of Google Script is JavaScript. So if you know JavaScript already, you don't have to learn any new syntax. If you don't know JavaScript already, you can use this as an opportunity to learn JavaScript. And I can tell you JavaScript is picking up. Okay, now don't quote me, but quote me if I'm right. Okay, so don't quote me yet. Okay, when I'm right, quote me. I think JavaScript is going to outrun Python. Okay, but that's my prediction. 10 years from now, if I'm right, you can quote my lecture back and go like, see, Tech said that 10 years ago. But if I'm wrong, just forget about it. Okay. Okay, so be there if you're interested. They have a limited number of paid internship, and they cannot determine who's going to be paid and who's not going to be paid until the beginning of fall 2018. So don't count on it being paid, but you will still get job experience, and it's cool. It's on campus. You don't have to go off campus. So that's the first one, and then the second one is women in STEM. And let's see, where is it? Yep, this is the one. Okay, this one is even better because there's a free lunch. No, I'm not kidding. I'm actually telling you the truth here. So if you click on this link, I can give you the link later on. Um, it's a panel, which means there are 6 women already in STEM. They're professionals already, so they are the panelists. So if you're interested in going in STEM, okay, we have at least 2 here. Are you guys interested in going into STEM field? Just a little bit. Well, if you can survive this class up to this point, I would say yes, okay? Because nobody takes this class for fun. Am I right? Are you guys taking it for fun?
I'm not. I don't even know anything about programming. This is just.
Okay. So if you're interested in getting into STEM and you're interested, you don't even have to be a woman to go here, because you might have a sister, you might have a daughter. I have a daughter. And I want to know, okay, what kind of challenges are there? Are there challenges? What kind of obstacles, and so on and so forth? I'm going to be there, okay? Well, and free lunch doesn't hurt either. So go ahead and RSVP. I can send you guys the link so that you guys can kind of register, pre-register, so they can get your free lunch. But if you have specific questions, bring your questions, because the whole idea is there are 6 panelists to answer questions related to, okay, does gender make a difference in terms of pay, in terms of promotion opportunities, in terms of treatment by your co-workers? Does it make a difference? If so, what kind of a difference does it make? And should we tolerate that? Should we continue in that direction? Should we change? How do we change? And so on. So I think that's going to be a productive dialogue, on Friday. Okay. In terms of culture, for those of you who want to do some background research before going there, you want to research Uber. Okay, that's the first company you want to research. Is how do they treat their female employees? Okay, just look it up. Okay, look up on Google and you will find a lot of information. The second one is Google. Okay, so Google, is actively trying to do something to curb behavior that is not desirable, but they got into hot water because of that too. So, so the question is, what should companies do, about employees, doing something that is gender specific? Okay, is it discrimination? Is it harassment? And if so, what should they do? What should the employer do? And what should employees do, to deal with those situations? So it's going to be an interesting event. I got a few more minutes. Why do you think we suddenly have this interest in, let's get more women in STEM?
They're trying to make more programmers. We need more STEM majors.
Yes. That's the bottom line, okay? That's the bottom line is, places like Facebook, Google, Uber, any high-tech companies in the Bay Area, they are running out of engineers. They're running out of STEM employees, okay? And then they look at the employees and go like, wow, 70 or 80% or even 90% are guys, male, okay? They go like, well, I think we can easily double the amount of available workforce by getting women into this field. Then we don't have to pay the guys as much money anymore. We pay everybody less because there are more qualified employees. So that is the drive, quote unquote, that's the drive from the perspective of the employers. Okay? So they're not really thinking about the welfare or equality or equity or anything like that. They're thinking about their pocketbooks. It's like, man, I don't really want to pay a software engineer $150,000 a year, and always thinking, is this guy going to switch and go to another company? I want to pay $90K at the most per year for this kind of employee and not have to worry that they are going to leave. Because if they leave, I got plenty of people who want to get in. So that's part of the reason why there's a sudden interest in getting women into STEM. And then the other second thing that's really interesting, this is something that I heard from the morning class, from 440, was in computer science. Originally, they actually started off with more women in the workforce than men.
Because it was secretaries. It was secretaries that were promoted to do programming. Because originally programming was considered just busy work, so you wanted teaches a position, they're like, oh wait, let us the men do it. Reverse situations over time.
I don't know exactly why that there's the reason, but that happened before computer science became quote unquote glamorous. Okay, I shouldn't use the word glamorous, but became well known and well paid and stuff like that. Who coined the name bug? When your program doesn't work right, you have a bug. Who did that? It was an admiral, right, in the Navy. Huh? Yeah, but the person who coined it was a woman. Okay, bug in program whose quote. Okay, that should be able to do it.
Oh, it's in my pocket.
Okay, software bug. And we're going to look for the history. Nope, that's not it. So anyway, the person who coined the term a bug to refer to a machine having a defect and therefore it is not working correctly was a woman who was also an admiral in the Navy, and she was working on one of the earlier computers, and I think the purpose of the computer was to compute the trajectory of projectiles, because that's one common application of computers in the Navy. So anyway, it's interesting how the population basically shifted over time to the point that it is now. We have two women, or two. Okay, we got two women in about 22 students in this class, which is about, what, 10%. And that's already more than some of the other classes. In CISP 440, we got 0%. It's 100%, men and 0% women. So that percentage is very, very skewed.
In the beginning, I was one of like 5 or 6 in the intro classes, and then as I got into the more intermediate classes, it was 2 to 3, and now it's like 2 to 3.
But why do you think that is the case? Because I'm not doing anything actively to that should result in that.
No,
I've asked some people about
not your
this.
fault. It's not the teacher's fault. I just feel like
No,
I really
from
don't
what I've
know,
talked to,
honestly.
a lot of women are discouraged because it's uncomfortable to be around so many men. Like from some people I've heard, it feels a bit awkward. But more importantly, like not every girl is very comfortable spending lots of time in front of a computer alone. it's a convoluted subject, and I can't speak for everybody, but some people have told me that.
Okay,
I
now,
was also really discouraged by my counselor when I was first starting.
interesting.
Yeah,
He
it was
just
actually a
On
big
what ground, though?
They were telling me to do art instead of computer science.
Now, did they?
So mad.
Okay, wait, but wait. Did they do that because they looked at your transcript and you had some indication that you have more
Had
leaning to the art side?
in all my math and science. I took all the science classes and everything. I took art classes just because I liked the teacher, but it was mostly just math and science that I took. And I was like, I know programming.
Interesting.
I wanted to take a programming class. That knew what I wanted to do. And they told me, you should try taking some art class. And I said, why? Because you might want to switch your major. I said, why would I want to do that?
Interesting. Okay.
I think it was a female counselor too,
Okay.
which is really ironic.
Well, the gender does not matter. It's more of the belief system, and also, possibly age. I'm getting a little bit on a slippery slope over there, but it has to do with the older belief that gender determines what a person should and should not do. The other thing that is kind of interesting is in population, for those of you who have taken 16 personality test, the MBTI personality test, the distribution of those personalities is not even, because there are 16 personality types. So you would think that each type should have about 6-ish percent in population, so it's all even. That is not the case. The rationals, the NTs, blah, NT, blah, those are the minorities to begin with. the SFJs are the majorities. Some of those types occupy more than double of their allocation. And then some of those types only have 1% instead of 6 point something, they only have 1%. And the interesting part is it's also somewhat gender dependent. So even though INTP, which is my type, is not exactly rare, but it is underrepresented in population. If you are a man, it is slightly underrepresented, but if you're a woman, it is way underrepresented. So that it has something to do with that too. So that's why the stereotype is there, because the majority is some type, and then the minority. If you are a minority type, they go like you're not the usual kind, So that might be actually what you encountered, was that kind of thing.
Yeah.
Yep. But it's unfortunate that the counselor is doing that, because the counselor are supposed to steer students to explore what they are good at. So until there's a sign and evidence that you're not good at something, I don't think they should tell someone not to consider some particular option. So, alrighty. So I'm going to end the lecture now. So sign up for those things, and I'm going to send you the link to register for the free lunch.